Example 2 says, a sausage company makes two different kinds of hot dogs, regular and all beef. Each pound of all beef hot dogs requires 0.75 pounds of beef and 0.2 pounds of spices, and each regular pound of hot dogs requires 0.18 pounds of beef, 0.3 pounds of pork, and 0.2 pounds of spices. Suppliers can deliver at most 1,020 pounds of beef, at most 600 pounds of pork, and at least 500 pounds of spices. If the profit is $1.50 on each pound of all beef hot dogs and $1 on each pound of regular hot dogs, how many pounds of each should be produced to obtain maximum profit? Now, hopefully you remember from previous videos that the first thing that you want to do for these types of problems is to define your variables. So let's go ahead and do that. So define variables. Now the question is asking us to figure out how many pounds of each should be produced to obtain maximum profit. So I'm going to go ahead and let x equal the pounds of, the pounds of regular that they should produce, and y is equal to the pounds of all beef they should produce. Okay, and the next thing that we want to figure out is our objective function. The thing that we are trying to maximize or minimize. So again, we're trying to maximize profits, and it tells us that it's a $1.50 for each all beef and $1 for each regular hot dog. So that is equivalent to saying 1x, or just x, plus 1.5y is equal to the profit. And then the next thing that we want to figure out is our constraints. Now, hopefully you saw in the last video, and this is going to be really common for these types of real world application problems where you can't produce a negative number of things. So just like in the previous example, we need x to be greater than or equal to 0 and y to be greater than or equal to 0. And what that basically says when we're graphing this is that we are restricted to the first quadrant because x and y need to be 0 or positive. Now, let's think about the other constraints that we have to deal with. Hopefully, it's clear to you that when you read the problem, there's actually going to be 3 additional constraints. And if that's not clear to you, maybe go back and read that there are 3 product or 3 ingredient constraints. So there's beef, there's pork, and there's spices. So I think the easier of the 3 to come up with first is going to be the pork restraint, because one of the hot dogs, the all beef hot dog, does not contain pork in it. So the constraint for the pork is going to be found in x. So each regular pound of hot dog requires 0.3 pounds of pork. So that's saying that 0.3x, and it says that at most they can provide 600 pounds of pork. So 0.3 times x has to be less than or equal to 600. So I think of the 3 constraints, that one is a little bit easier to come up with since it only deals with one type of hot dog. Now, the beef, it says let's see, a regular hot dog requires 0.18 pounds of beef. and an all beef hot dog requires 0.75 pounds of beef, and they can deliver at most 1,020 pounds of beef. So I'm gonna set that less than or equal to 1,020. And then for the spices, both of them require 0.2 pounds of spices, so 0.2x plus 0.2y, and they have to deliver at least 500 pounds. So notice that the inequality symbol on that last constraint is in the opposite direction than the previous two. So what I'm going to do now is I'm going to go ahead and quickly graph these inequalities. Okay, just so that I didn't bore you, I've gone ahead and made each tick mark on our XY plane valued at 200, and then I've filled in every 1,000 units. And I've gone ahead and also graphed the line that represents pork. So I set 0.3x equal to 600. So basically I just took the inequality symbol and replaced it with an equal sign. And then if you divide both sides by 0.3, then you end up getting that x equals 2,000. So I've gone ahead and I've graphed that line in green there. Let's graph another one. So let's graph the beef. And the way that we're going to do that is very similar. So I'm going to take the inequality and change it into an equation. And I'm going to solve for y. So if I subtract both sides by 0.18x, then I will get 0.75y is equal to negative 0.18x plus 1,020. And then I can divide both sides by 0.75 and get y is equal to, so I went ahead and I threw that into my calculator and got y is equal to negative 0.24x plus 1,360. Okay, so our y-intercept there is 1360, so that's going to be approximately here. And our slope is negative 0.24. And I'm doing this pretty roughly, so this is why we're going to need to do some systems to get these values, because I'm kind of just eyeballing this. Okay, so I've went ahead and I've graphed that blue line, and now let's use red for that third constraint. So I have 0.2x plus 0.2y is equal to 500. I'm going to try to solve that for y. This one has a little bit nicer numbers. And so I get y is equal to negative x plus 2,500. Okay, so 2,500, let's see, 204, so that'd be right here. And then since the slope is negative 1, we know that it's also going to go through 2,500 here. Again, I'm going to rely on my ruler because it's a long ways to freehand that. Okay. All right, so it's going to look something like that. Now, again, I would like you to pause the video and figure out where the feasible region is going to be based off the direction of all of the inequalities. Okay, hopefully you've paused it and figured out that our feasible region is going to be this tiny triangle right here. Although it's small, that sucks, but the nice thing about it being a triangle is that there are only 3 vertices, and I'm going to highlight them in orange here like that. So I've gone ahead and I've done that. The bad thing is that you are going to have to solve for all of those because none of them are really clear from looking at the image or the graph. However, since 2 of them fall on the green line, we do know that these ordered pairs are going to be 2000 comma something, and this ordered pair is also going to be 2000 comma something. And I just don't even know about that third one. So I'm going to leave it to you to solve and figure out how you get those, but I will give you the answers for them. So the bottommost vertex is 2000 comma 500. The top right vertex is 2000 comma 880, and then the third vertex is the point 1500 comma 1000. So you just need to solve some systems of equations to figure out those vertices. All right, so I've gone ahead and I've jotted down our 3 vertices, and it'd probably be helpful to have our objective function as well, which was x plus 1.5y is equal to our profits. Now I'm just going to go ahead and very quickly throw these 3 vertices into my profit function and see which one yields the largest profit. So I went ahead and I plugged all of those in, all of the vertices into our profit function, and we see that this vertex 2000 comma 880 yields the highest profit. So what can we say? We can say selling 2,000 pounds of regular and 880 pounds of all beef will yield a maximum profit of $3,320.